Hi and hello. Welcome to the lecture series of Digital Electronics. This is Naveenraj from Department of CSE IoT, and today's topic will be a half subtractor. Okay. So normally, whatever the electronic device you take, you will be having some digital circuits. Okay, inside the calculators or mobile phones or everywhere. Every electronic devices which you are using need to be do some calculations, do some operations. Okay. So for that, you will be having some circuits, circuits like adder, subtractor. So in that manner, you will be having one half subtractor. Okay, so that is the today's topic. This half subtractor subtracts two single binary digits A and B. Okay, that means it has two inputs, that is different, and two outputs. Okay, that means A and B are the two inputs, and the difference and borrow are the two outputs. So in adder you will be having sum and carry. Similar manner you will be having difference and borrow. So the borrow signal represents an overflow into the next digit of the multi-digit interfacing subtraction. Okay, so when you're using multi-stage subtract circuits, you will be having that borrow will be carried out to the next circuit. Okay, so in order to understand clearly about the half subtractor, okay, you can see the truth table which is shown in the figure. Okay, that is inputs are A and B, the outputs are difference and borrow. The two inputs are 0 and 0. So for example, if both conditions are 0, the output difference and borrow also 0. Then if on any one condition, so either it may be B or A, okay, so it will be the one will be in normally in adder it will be 1, but here during subtraction time the 0 minus 1 we need to borrow some terms digits from previous ones, because the you will be having 0 1, so 0 minus 1 will be your 1 and 1. You need to borrow one thing. Okay, and what is your third condition? 1 and 0. So what is 1 and what is 0? The A inputs having 1 and B is having 0. That means 1 minus 0 will be your 1 difference and borrow will be 0. Then take the final inputs are 1 and 1. So here the 1 and 1 means both inputs are same. That is both inputs are the 1, which means 1 minus 1, difference also 0, borrow is also 0. So it is not thing that every time the same condition will be working. So it depends upon the based on the input given in the circuit, it will react. Okay, so not all the times it produces 0, or not all the time it produces 1. So based on this is the condition. So if you take any subtractor circuit or this half adder or half subtractor circuit, you need to follow this. Okay, this is the truth table. Next is you are solving the truth table like what we done in the adder circuit to solve. So same here, you need to draw the K map, that is nothing but mapping the input and outputs together in the pictorial representation. We call it as a K map. Okay, the first one is for borrow 0 0 and 0 and 1 1 0. Okay, so like that you will be having two K-map circuit, one for difference, one for borrow. So once the completed, you can easily draw the design circuit from the help of your K-map. The K-map is correct, you can easily draw your designing circuit. Okay, easily. So next, look at the full subtractor. The similar manner, what is the difference between the half adder and full adder? The half subtractor, full subtractor. So all the half subtractor will having only two inputs, either it's half subtractor or half adder. You only having two inputs. When you coming to the full subtractor or full adder, so you will having three inputs. So the output may be differ from. Okay, so you need to be carefully given the input signal. So yeah, 1 bit full subtractor subtracts these 1 bit numbers of its effects written in A, B and Bn. It has two outputs, difference and borrow. So look at the truth table. Okay, so here the A input is 0, B input is 0, and B in is also 0. That means difference and bar all 0, 0. Similarly, we take the last condition 1, 1, 1. So B out 1 minus 1 0. Again 1 minus 1 will be 0. So similarly, so the all the conditions has been checked in the truth table with respect to the inputs A, B and B in given, and respective borrow and difference. Okay, then solving truth table using the K map. Similarly, it's a 3 bit input. The 2 power 3 will be 8 cells will you be having. So what are the values you get in the truth table, that you can copy it cell by cell, and you can form a 3 pairs. Okay, you will be having some 3 pairs over here. Okay, so from the help of this your K map circuit, you can draw this designing circuit which will be having so XOR gate, AND gate, and you will be having NOT gate is also. In order to take the complement of these 3 inputs, you can also fix complement also. Okay, so